to this week's presentation. We have our very own Dr. Scott from NVU Johnson. She teaches in the psychology department. So she is here and accessible to you all. So even if you don't get your questions answered today, she is here and you can always reach out to her. Right?
Yeah, absolutely. Absolutely.
So she's going to talk to us about some research she's been doing for the past couple of years, thinking about how our interaction with nature affects our brain and our nervous system. So a little bit of a different topic than we had last week. Last week we were in biochem, now we're in some nervous system and thinking about how our bodies respond to different environments. So I'm going to start the sign-in over here again. We're going to go up and around and down. I think it worked out last time. Did it seem okay last time? Seems a little better. So up this way, across, and down. Ending here with me, okay? Okay, well with that being said, let's welcome Dr. Scott.
Hi. I'm super excited to be talking to you all today. I don't know if I see any familiar faces, but also my vision's kind of not the best.
Don't lie.
Oh, hey, happy, I'm so happy you're here. Okay, so yeah, got some familiar faces. Come take a psych class with me. I'm biased, but I think it's, the coolest. This talk will focus on my dissertation research, which mainly explored how the brain, how our peripheral nervous system, so indicators of physiological stress, how that changes when we're exposed to different kinds of environments, specifically looking at the influence of nature and natural environments. Before I jump into that, I'll start by talking about some of my background and kind of early research. I went to college in DC at the George Washington University, was fortunate enough to have some scholarship money there. I told this to some students in the exploration class, but when my colleague, Dr. Gina Moreau, and I went to talk about psychology, but I actually came into college totally undecided, maybe like some of you. I was in DC, so I was like, maybe politics will be interesting to me. Turns out it wasn't at all, and I just found myself taking psychology classes over and over again. So eventually I was like, I should probably major in this. I then started working in different research labs towards, the upper end of my college career. So I worked in a health behavior and cognition lab and an attention lab. And so this is where I started to get a feel for research and laboratory studies, and I found that to be a lot more interesting than kind of like basic office work. So I was like, well, I guess I should continue in this direction. And then after college, I spent 2 years working for a research company called Westat. There's actually a bunch of research companies out there. My company got government contracted to carry out national surveys and studies on various government-funded projects. So I worked on a couple of different projects, a project relating to health policy, and then a project relating to education. So what's cool is there's actually, we tend to think of research as just academic, but there's actually a lot of both privately ran, nonprofit organizations that either get contracted or do research themselves. So you can also do research in an industry type setting. And so that's what I did for a couple of years. And then I decided that I should go back to graduate school and get my master's and Ph.D. So there was only so far up I could move in my position. And I knew that a Ph.D. would give me more opportunities. So I then went to grad school at the University of Utah, where I got my master's and Ph.D. in psychology. And I graduated from there in 2021, so I'm very fresh at NVU. This is my second year. But basically, at the University of Utah, I was able to really kind of like blend all of my interests together and all of my kind of prior experience together. I started off initially working with Dr. Bert Uccino, looking at how social relationships influence health, specifically cardiovascular health. So we used indicators of physiological stress and then looked at how different social relationships impacted those biomarkers. But while I was there, I also discovered my now second advisor, Dr. Dave Strayer, who became really famous for his research on distracted driving and attention. Basically, the idea that attention is a limited resource. So when we multitask in our everyday life, we are often performing worse at both of those tasks than if we were to just do one of those tasks alone. So his lab was really focused on attention in applied settings. So what happens when you're texting while you're driving. But then also his second line of research looked at what happens to attention in the absence of those distractions. So for example, when you're out into nature and you may be away from multitasking, you may be away from all the millions of things that you're doing every day, what does that do to attention? So I kind of discovered that line of research while I was there and kind of like begged him to let me be a part of that. And then that eventually worked out, and so I was co-advised by him and my other advisor, Dr. Bert Uccino. So kind of like in life, you often, you start somewhere and then some opportunity comes along and then you end up kind of like on a slightly different path. But it worked out super well for me because I basically took kind of everything I had learned about like physiological measures of stress, about attention, and applied that to understanding how different biomarkers might be changing when we are outside in nature. So that's kind of my basic background in terms of how I got to where I am. So I'll transition now to talking about my dissertation research, which looked at different biomarkers, both of brain activity and of physiological stress when participants were immersed out in nature on a 4-day nature trip. So the basic theory behind this research is mostly driven by two theories in the field that both kind of emerged in the early 90s. So attention restoration theory and stress recovery theory. Both theories suggest that our environments play a role in our attention and our physiological stress, with the idea being that natural environments might restore attention. So if attention is a limited resource, we might over time in our everyday world experience depletion of that resource, especially for multitasking, if there's a lot of stimuli that we have to attend to. So the idea being natural environments might be able to restore attentional resources and reduce physiological indicators of stress. And so traditionally studies have looked at comparisons of physiological measures of stress and of cognitive measures of attention, kind of looking at natural versus urban environments. And I'm not here to like hate on cities. I think there's a lot of really good things about living in an urban environment, about technological advances that we've made, but we do know from decades of research that technology, especially when you're multitasking, and urban environments, just because there's so many stimuli that you have to attend to. Like if you think about crossing a busy street, you really have to pay a lot of attention. So it's not that it's not that urban environments are totally bad, it's just that natural environments might give us a way to kind of replenish depleted attentional resources and restore some of that stress we might experience in our everyday lives. So that's kind of the idea, the theoretical reasoning behind that. So I talked a bit about attention restoration theory. Again, this was the basis for some of our work, but a bunch of studies since this theory emerged in the 90s have shown that exposure to natural environments improves attention, creativity, working memory, and some recent meta-analyses, which are basically a bunch of studies combined together to look at the overall strength of an effect, have found that the greatest improvements might be happening with working memory specifically when it comes to exposure to nature. So working memory involves holding items in your head, sometimes while you're doing another task, but basically keeping information in memory before it gets converted into long-term memory. So, you know, whenever you're trying to like memorize information or like try to remember like a list of things you need to get at the grocery store, that's using your working memory. So we know that natural environments should result in improvements on working memory tasks. And specifically, a lot of this research had been done with cognitive measures, using measures of behavioral performance, so just kind of task-based measures, but no one had really looked at neural measures relating to working memory performance. On the stress recovery side of things, decades of research have found that exposure to natural environments improves physiological indicators of stress across a wide variety of physiological measures, including decreased cortisol, so that's a stress-related hormone, decreased heart rate and blood pressure, increases in other physiological markers like heart rate variability. We'll talk about that more in a second, but an increase in this case is a good thing. Increases in killer T cell activity, that's an immune biomarker. Killer T cells are known to help fight off cancer cells, part of your innate immune system, so that's also a good thing. As well as just improvements in self-reported measures of stress and self-reported measures of mood. So exposure to natural environments consistently show improved positive mood, reduced negative mood. So all this research has been done on this topic, but we were really interested in trying to identify reliable biomarkers from both theories. Oftentimes, people in this literature tend to fall into like one of either camp. So there tend to be like the attention restoration theory folks and the stress recovery theory folks. And we were interested in the idea that maybe these theories are happening at the same time. So maybe as we experience changes in stress physiology, that frees up cognitive resources, or vice versa, but the idea that changes in stress and attention are probably co-occurring. So rather than these theories being separate, we propose that these theories interact together so that changes in attention and stress should be co-occurring in nature. But there hadn't really been any studies that had examined both measures of physiological stress and neural biomarkers of attention. So that's where our study came in. And I won't get into that model, but that basically was our kind of theoretical reasoning of how changes in stress and attention might be co-occurring. And again, I won't get into like the nitty-gritty details there. But essentially, we wanted to see whether changes in in stress and changes in attention were co-occurring out in nature. And again, although a lot of studies had explored measures of cognitive performance in nature, not too many had looked at neural biomarkers of attention. So we were interested in what's happening at the neural level, how is brain activity changing in response to this change in environment. So it turns out we can actually measure brainwave activity and bring it out into like the desert, which is pretty cool. And we can do this through using a tool called electroencephalography, or EEG. So EEG is a non-invasive way of measuring brain activity, and you do this by placing electrodes on a person's scalp. So those electrodes then pick up brain wave activity that's on the surface, in the cortex of the brain, and it's recording from a population of neurons. So it's giving us like real-time brain activity of those neurons firing, which is really, really cool. And it allows us to look at brain activity in response to an event or a stimulus. And those are called event-related potentials. So through the use of EEG, we were able to look at neural correlates of attention. And then if you remember, when talking about kind of like the biggest findings from the nature literature on cognitive performance, the biggest improvements were seen on working memory tasks, but no one had really looked at the neural mechanism behind that. So through event-related brain potentials, we were able to look at a neural measure of working memory, which is called the P300. So the P300 is thought to be this brainwave potential that indicates how much attention is being paid to a stimulus and thought to be involved with memory updating. So I will kind of like clarify what I mean by that in a minute. But essentially you can generate this brain component basically anytime your brain is sort of updating in response to new information. So one of the most reliable ways to elicit that brain component is through what's called an oddball task. This is where you present people with, you can do it with letters, you can do it with numbers. I knew someone that did it with like Star Wars figures. So you can use any kind of stimuli, just one stimuli has to be presented 80% of the time, and another stimulus has to be presented 20% of the time. So one stimulus has to be really frequent, and another stimulus has to be less frequent. So in this case, we just were boring and used X's and O's, but basically either an X or an O was presented 80% of the time, and then the other letter was presented 20% of the time. Some people got X 80% of the time, some people got O 80% of the time. That was to kind of like counterbalance the stimuli to make sure it wasn't the letter themselves that affected the results. But essentially what this does is allow us to see how brain activity changes when you see an infrequent stimulus. And so when you see an infrequent stimulus, so in this case that would be that like X that's presented 20% of the time, your brain actually updates and increases in activity. And we see it's called the P300 because it's a positive peak. So the electrical activity itself is going in a positive direction. It's a positive peak around 300 milliseconds. So that's like the stimulus is presented and 300 milliseconds later, your brain is updating in response to that infrequent stimulus. So like the really faint dotted line is whatever frequent stimulus is presented 80% of the time. The more solid dotted line, that big spike in brain activity, is when the infrequent stimulus is presented. So that's your brain like updating. And then the solid line is the difference wave. So it's the average activity of the infrequent minus the frequent trials. And the reason I bring that up is because the difference wave is what we use to compare across different conditions. But that's essentially what that looks like in terms of your brainwave activity when your brain updates to some new or infrequent stimuli. So that's basically how an oddball task works. So essentially we can look at the amplitude of this brain component and we can get information about attention capacity. So basically, the P300 is thought to reflect memory updating and the capacity to allocate attentional resources towards this updating process. So basically, a higher amplitude would indicate that you're paying more attention to the stimulus. So it's an indicator of attentional capacity, essentially. Previous studies have found increases in P300 amplitude after meditation, exercise, and yoga. So based on that, I hypothesized that in nature, we should also see an increase in the P300 if nature is having this restorative effect on attention. So if nature is increasing attentional capacity, then we should see this reflected in an increase in the P300. And no one had really looked at this before, so we were really unsure what we were going to find related to that. At the same time, we were also interested in changes in stress. So a really crude basic overview of the stress response, like you see a bear in the wild or you see some sort of other threatening stimuli, your amygdala in your brain is interpreting that threat, is sending the information to other parts of the brain so that your brain can respond appropriately. So it's sending information to the hypothalamus, for example, which is releasing a bunch of hormones. It goes through other structures. And then your autonomic nervous system is also activating. So this is what we think of as the fight or flight system. Your sympathetic nervous system is acting as the gas pedal on your stress response. So your heart rate's beating really fast, your breathing's becomes a lot faster, your pupils are dilating, and then your parasympathetic nervous system kind of kicks in and acts as the brake once the stressor has passed. So when your parasympathetic nervous system is really active, that means it's kind of slowing your body back down to its baseline. It's slowing your breathing down, your heart rate down. So we wanted to use a measure that tapped into parasympathetic nervous system activity to see if nature is also reducing stress and kind of essentially activating the brake on the stress response. And so you can measure this through electrocardiography. So this is similar to EEG. It's just electrical activity of the heart instead of electrical activity of the brain. And same thing with EEG, we can place electrodes on the chest and we can get electrical activity of the heart. So essentially through this electrical activity, we are able to look at what's called heart rate variability, which is thought to be an indicator of parasympathetic nervous system activity. So essentially, heart rate variability is like the distance between your heartbeats or your interbeat intervals, and actually greater variability is thought to indicate better regulation over the stress response, greater parasympathetic nervous system activity. So that's what we were interested in measuring. with the hypothesis that if exposure to nature does actually reduce stress and increase parasympathetic nervous system activity, then we should see increases in heart rate variability. And so we had our measure of brain activity, we had our measure of physiological stress, and we were interested in looking at whether those changes were correlated or not, if we would see changes in either measure. We also, because we were taking participants on like a 5-day nature trip, we also had different subjective measures to kind of rule out whether other variables could be at play. So we had measures of social connectivity, physical activity, sleep disturbance, as well as measures of mood and physiological stress, because we were also interested in whether these things were changing in nature. And so we had a within subject study, meaning like all participants are participating in all sessions of this study. They came into our lab 1 to 2 weeks before the trip. We tested them during the trip, and then they came into our lab 1 to 2 weeks after the trip. So they each completed 3 testing sessions where we measured their brain activity, measured their physiological activity, had them do these tasks, like all the different things. It took like 2 hours each session. And we recorded all the testing outside. This was to control for any differences that could be due to just being outside versus being in nature. So when they were outside, actually I'll like illustrate this better. For the first and third testing sessions, so before the trip and when they came back from the trip, they just sat outside in this little pod in a concrete building outside of the psychology building. Out in nature, they sat along a riverbank where we were testing. So this was their second testing session. So that's what the testing sessions themselves looked like. They sat in these cool looking like soccer mom pods to just protect against weather. Even though with the building they were covered just to control for everything, keep everything as standardized as possible, they sat in the pods for all 3 of their testing sessions. They are pretty effective at keeping weather out. So that could be something to look into depending on what your hobbies are. So we were able to collect a sample of around 67 participants. So we actually went on 3 different trips to collect this sample. This was some of our demographic data. Most of the students were around college age. We had a pretty even distribution in terms of male-female. A majority of our participants were identified as white, non-Hispanic. In each testing session, we set up all the testing, put all their electrodes on. We had the 10-minute physiological recording to get their baseline stress levels. They did the oddball task, and then they were also completing their subjective measures, and we removed their electrodes. So that was the same across all 3 sessions for each participant. So each procedure was the same. I'll show you a really quick video so you guys can see, you all can see what our trips actually looked like. So what participants actually did, and because I've been talking for a while, so to give you a break from listening to me. But we made this video as a recruitment video to recruit participants. One of my lab mates has a partner in the film industry, so she was able to make it look really great. But this is essentially what participants experienced when they were on these trips with us.
It's hard to place measurable value on nature. We all know that being in nature makes us feel better, but what we don't know is why. It's the Applied Cognition Lab's primary objective to find the answer to this question. We're currently doing a study to determine how nature affects the brain. We bring participants on a 4-day camping trip to the San Juan River near Moab, Utah. We lead hikes to Anasazi Ruins and around the gorgeous protected lands of southern Utah. We also have meals prepared fresh daily by our camp cook, compensate for travel from Salt Lake City, and we pay participants for their time. We measure participants' brain activity on simple tasks before, during, and after the trip in order to see if there is any change in brain functioning as a result of immersion in nature. These studies require time, energy, and interest, but most importantly, they require participation. None of what we're trying to accomplish is possible without participants who are willing to join the study. By doing so, you help us better understand the natural world and our place in it. We'd like you to join us as a participant on our next research trip. Please reach out to the Applied Cognition Lab today. We can't wait to experience this with you.
Okay, so pretty fun stuff for them. Like it was essentially like basically a paid camping trip, but that's hopefully gives you an idea of what these trips kind of looked like. So they were out there for about 5 days, and then they had meals provided, went on hikes, hung out at the campground. We measured their brain activity. It was a win-win, I think, for most people. And then again, we tested their brain activity when they came back from the trip as well, about like 1 to 2 weeks after the trip. So in terms of what we found, with regards to the P300, as predicted, we did see an increase in P300 activity. So this is the difference wave compared across the 3 testing sessions. So the kind of like darker dotted line indicates the big increase that you see there at post-testing. So once they came back from the trip, there wasn't a significant difference between their first testing session before the trip, their baseline, and while they were on the trip, but we did see this big increase in P300 amplitude once they came back from the trip. So that's what we saw in terms of brain activity. In terms of heart rate variability and heart rate, we actually found the opposite of what we expected. So we expected that heart rate variability would increase while participants were in nature, and that heart rate itself would decrease as an indicator of stress recovery. But we actually found out they were more stressed out in the desert. So we saw a significant decrease in heart rate variability and a significant increase in heart rate. So that was totally unexpected and completely contradictory to everything that the field would suggest. But we saw it replicate 3 different times. So we saw it replicate across all 3 trips. So my advisor was like, all right, go ahead, try to publish it. But it was a very odd finding. I'll talk more about why we think that happened. But essentially, we didn't see changes in, we did not see changes in self-reported measures of physical activity, social connection, and sleep. So that would indicate that those things weren't having any sort of effect on our results. Because, when you're taking people out into the wilderness, it could be that those things might have an impact on brain activity or on physiological stress, but we didn't see changes, at least from self-reports of those measures. We did find that even though physiologically participants were more stressed out, they actually reported subjectively that they experienced less stress and lower negative affect while in nature. So that was also really interesting because it kind of conflicted with the physiological results of increased stress. So even though they were saying they were experiencing less stress, physiologically they were elevated in the desert. And then again, we saw increases in P300 amplitude, which indicate greater attentional capacity and or greater attentional resource allocation. So if attention is a limited resource, we kind of see with an increase in the amplitude of the P300, that would indicate that greater attention is being paid towards the stimuli and towards the task itself. So that could mean greater attentional capacity, or just that more of the more cognitive resources are being allocated towards this task. We didn't see any relationship between P300 amplitude and physiological measures, so kind of also unlike what we predicted, it didn't seem like these changes were co-occurring at all. It did seem like they were happening somewhat independently. But that's kind of our basic overall findings. Some limitations include that we didn't have a control group with this study. So these were participants that wanted to go on these trips, that were kind of opting into this. And so because of that, we also had somewhat of a biased sample. Like these were participants that wanted and were able to go on a 4 or 5 day nature trip. So there were probably people that already liked the outdoors. So that was a limitation of our research. Ideally you have samples that are more representative. It'd be interesting to see what happened if you took people that said they didn't like nature and put them out into nature. We can't say what would happen based on our sample with that. And we also didn't have random assignment. So because we didn't have a control group and we weren't randomly assigning people to either condition, we can't make statements about causality. So although we saw changes within each individual that replicated, future studies still need to have control groups and use random assignment to really better understand this relationship. And then we saw from our self-report measures that we don't think that changes in exercise or sleep or social connection on the trip affected the results, but we only used subjective measures of these things. So future studies could also look at more objective measures of these indicators. So like have people wear pedometers to track physical activity. We also can't really say whether our results were due to maybe like decreases in technology. We didn't measure and control for technology as a variable. So that would also be something to look at in the future. So that is kind of the overall, that was kind of overall what we found. So again, found that P300 amplitude increased once people returned from the trip. So that indicates greater attentional capacity. We saw very odd findings with physiological stress. So people were reporting that they were experiencing less stress, but physiologically they were still elevated. And we don't fully know why that is. It could be that on the trip they experienced a lot of like social dysregulation. Like if you imagine when you go on a camping trip, you're kind of removed from your everyday environment, that might elevate physiological activity. Being around people you don't know might elevate physiological activity. Also, attention can sometimes elevate physiological activity. So it could be that, just being in a novel environment caused participants to be like more aroused and more excited. That could have increased physiological activity. So we're still not really sure why we found that finding, but it did replicate across 3 different trips. So it was a pretty robust effect. So in terms of future research on this topic, again, we were one of the first to look at neural biomarkers of attention out in nature, but there's still a lot we don't know about how the brain changes in response to changes in the environment. So going from a more urban environment to a natural environment, or just being outside in general. Future research definitely could continue to explore various neural biomarkers while people are out in nature. We also don't really know what kind of like dosage or how much nature is needed to see these effects. So is looking at pictures of nature good enough? Is going out there for a 5-day wilderness trip, like is that what is needed to see these changes? We don't really know. So looking at the amount of nature and manipulating levels of dosage would be a good area of future research. Also looking at different environment levels. So we took participants out into the wilderness for 5 days, but you could also use like nature virtual reality, nature-based imagery, because not everyone has access to like wilderness areas, or not everybody can take the time to go on a 5-day nature trip, right? So looking at, what level of nature is needed to see psychological benefits. Looking at different environment types. So the desert of southern Utah is very different than the woods of Vermont, right? So it's still unknown like what type of environment is needed to see these effects. Since our study was only done in Utah, I can't speak for whether we would see the same thing here in Vermont. But looking at different kinds of environments would be an interesting area of future research for this too. Looking at individual differences, like does preference for nature have anything to do with this? Some people are really like uncomfortable or stressed out being out in nature, so we don't know if they would necessarily experience changes in brain activity. And then also looking at this research with more diverse populations. Again, our sample was majority identified as white, non-Hispanic, so looking at whether these results extend to other populations, other race ethnicities. Also, it was mostly college age, so looking at this with older adults, for example. Also looking at clinical populations, so for example, individuals with attention-related disorders like ADD or ADHD, looking at those individuals and how nature might affect them would be interesting. Same with, we know one of the most robust psychological benefits of nature is improvements in mood. So it would also be interesting to look at this research with individuals who are diagnosed with depression and anxiety. So there's a lot of different areas for future research, some of which I hope to do here at NVU. And yeah, again, this was my dissertation, so this was years and years of research that involved a lot of people. So in addition to my lab mates and other graduate students, we also had a whole bunch of undergraduate research assistants who helped us with these really massive studies that required like a lot of logistical planning and like a lot of testing. So we definitely wouldn't have been able to like pull it off without them and without each other. So it really, I always say it's like the best example of team science, because these studies were so involved that literally every single part depended on another part. So we needed, so much help to be able to pull this off. Some of our research has been published in various journals, in addition to the media. So some of our research has been featured in National Geographic and REI, as well as in 2 popular pop psychology books, one called The Nature Effects and the other called Blue Mind. And then we also have this research published in academic journals. If any of you are like super interested and want to nerd out about that, feel free to email me and I can send you those articles in case you wanted to read about this in more detail. Or also just swing by and chat with me. I'm just over in the other building and my floor is pretty lonely. Come by and I'm happy to chat about this or chat about anything, anytime. I'm in WLC 312. Definitely take a psychology class. And that's all I have, but happy to take questions about anything I talked about psychology in general. Priya.
So I have a question.
Yeah.
What were the 2 theories that you talked about? You said stress recovery theory and what was the other one?
Yeah, stress recovery theory and attention restoration theory. A fun fact is that that isn't relevant to you all at all, but a fun fact about those theories specifically is that attention restoration theory was kind of coined by this guy Kaplan, and it was actually his graduate student that came up with stress recovery theory. So his grad student came up with like an opposing theory, and now people in the field are pretty divided over which one. So some people think it's really stress recovery is the reason we see these benefits in nature. Other people think it's attention restoration. But the 2 of them debated back and forth for several decades. And yeah, the stress recovery guy was the attention restoration guy's grad student. So that's fun. So like an awkward thing that can happen sometimes. Good question though. Any other questions? Yeah.
So in terms of the time point when you were out on the trip and you did the oddball test and the testing for heart rate variability, was there, what was the reasoning behind the time point you chose, and would there have been any benefit of doing it more often?
Yeah, it's a great question. It would have been really cool to like test everyone on day 1, then test everyone on day 2, and test everyone on day 3 of being on the trip. But we just couldn't pull that off for just like pure logistical reasons. So we tried to keep things the same as much as possible. So we tried to keep every participant's, all 3 of their sessions at the same time. That way, like, because we know that, for example, like time of day can have an effect on physiology. So we tried to keep like timing consistent. But yeah, the only reason was we didn't have like the sheer logistics to be able to pull off more sessions within the trip. That would be cool though. Yeah.
So is their justification for doing it more often? Can heart rate variability change more frequently? Like, so it could be that maybe that if you looked at it more often, your results might have been more on par with what you were expecting, or?
Yeah, it would have been interesting to like track the change. The more kind of theoretical reasoning behind it, I guess, would be to look at, if we expect that these changes kind of happen in a linear fashion. So the more time you spend in nature, the greater amount of resources will be replenished, right? So then it would be interesting to see like what happens on day 1 of being out in nature versus day 4. So like theoretically, we're interested in tracking that change over time. But yeah, more sessions, like more physiological measures is always good, because then kind of like any differences that could be due to the environment just get canceled out over time. Or like any differences, I should say, that would be due to factors outside of what we're interested in might cancel out over time. So like it would have been probably more reliable if we had been able to collect more, if people had been able to do more testing sessions while in the desert. We just couldn't pull that off logistically. But for example, has anyone seen the show Alone? Like, yeah, it's such a cool show, right? So like my pipe dream would be to like go test those participants, right? Because they're out there for like 90 days or 100 days for those of them that make it. But that would be like a really cool example of how you could track that change over time. Like what happens, like what happens before they go out there, what happens on day 5, what happens on day 100. Like that's crazy. Maybe we'll never know. Maybe one day I'll get money to go do that. Who knows? But yeah, that if you had more time, you might be able to pull off like more testing sessions and a lot of help, Yeah. But yeah, it would be really, really cool to do something like that. What other questions? Yeah, please.
You say something about biomarkers. I'm not sure, what is that?
Yeah, biomarkers being just like physiological or neurophysiological indicators. So by biomarkers, kind of like any change in your body or brain that's happening. Yeah, good question. So the specific biomarkers I looked at were the P300 and heart rate variability and heart rate. But there's a lot of different like physiological indicators you can look at. There's a lot of different measures of brain activity that you can look at. The P300 was just one example, but my lab mates also looked at different brain wave components and found kind of a similar pattern actually. So I didn't talk about that just for like time's sake and not to like bore you guys to death, but we also saw similar changes in other brain components that also have to do with attentional processing, just in different ways. So for example, my lab mate looked at a brain component related to error monitoring. So basically your brain's response when you've made an error. And similar to the P300, increases in amplitude of that component indicate that greater attention is being paid towards errors and error monitoring. So basically your brain's like, I don't want to make that error again, I'm going to pay attention. And so we found increases in amplitude of that component after nature exposure as well. So we're starting to see like a pattern in terms of brain activity and attention, where we're starting to see like increases in those components, which would then mean that there's more attentional capacity at play after people are exposed to nature, at least in our studies so far, to add all the caveats. Yeah, great questions. Any other questions? Yes, in the back.
Hi. So when you were talking about the P300, you said that your brain would update and increase in activity. When you said update, did that just mean like react?
Yeah, so essentially that big like peak that we saw is your brain activity in response to an event. So this is thought to be related to updating, like memory updating, because essentially brain activity is spiking when you see that infrequent stimulus. So your brain's like, X, 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 oh, okay, something's different, and your brain pays more attention to that. So that increase in attention is reflected by this increase in amplitude. So kind of this increase in brain wave activity. So literally that means like electrical activity of the brain. Yeah. And another cool fun fact about the P300 is it's actually pretty like widespread throughout the brain. It's a pretty like robust effect. It's not localized to a particular brain area. This is just like happening in the whole brain. But yeah, so it's thought to be involved with memory updating for that reason. Great question. Other questions? Yeah, way back.
Can you go back to a slide with intention research theory?
Yeah. This one?
Yeah.
Attention restoration theory. Yeah. Yeah, questions about that? Yes.
I was just, so I know your study only had willing participants who we can probably assume they liked and wanted to spend time in the outdoors for 5 days.
Yep.
But do you know if there's been any somewhat similar studies with people who don't like the outdoors?
Yeah, it's a great question. Not to my knowledge. I think that's like a really good area for future research. Like my guess would be that if people are super stressed out or they're just like really uncomfortable, they may not experience these changes in attention because like their cognitive resources are being devoted towards the stress that they're experiencing while they're out in nature. So that would be my guess, is maybe they wouldn't show these changes, but we don't know because there hasn't been a study related to that. That's a really good question though, and I think an important area for future research. My lab was the only lab crazy enough to actually like bring all of our equipment out there and test people out there. So to my knowledge, we're the only people that have really taken people on these immersive like 4-day wilderness trips. There have been other studies that use nature imagery or have participants go on nature walks. And those studies have used random assignment and attempted to recruit more diverse samples. But in terms of like immersive nature, we're the only ones that I know of that are doing this. But yeah, it's a really good question for future research. Same with if you take people who work outside all day. They also might not feel that nature is restorative because they're working outside all day. So it's unknown whether we see these changes in other populations. I can only speak to people that wanted to go on a paid camping trip, basically. But with biomarkers like brain activity and physiology, the idea is that because there's such objective measures that that even though this sample is biased, the fact that we still saw these changes in brain activity is pretty interesting, or at least worth exploring more. But yeah, good questions. Any other questions?
Need National Geographic to give you a grant.
Yeah, I know. We've gotten I think like REI came and recorded a video of us once, but like so far no one's wanted to like invest tons of money. But yeah, we did have a photographer from National Geographic come on one of our trips and wrote an article about it. So I can send that article to anyone that's interested. But yeah, mainly my advisor was already kind of well known in his field at the time for attention. So that's kind of how we also started getting like media attention, is that he was already pretty well known for his work on attention. And then, kind of had this side passion project of looking at what happens when you go out into nature and how that changes attention. So yeah, that's how it started. Other questions? And again, in formulating my hypotheses, I looked, since we were the first ones to really look at this, I looked towards literature on meditation, on exercise, because those are kind of like similar kind of like interventions or things you can do that are restorative. So even if you're not like the biggest nature or outdoor fan, these biomarkers have been looked at with things like exercise and meditation, and pretty robustly and reliably have found increases in P300 amplitude, so increases in attentional capacity after meditating, after exercising. So even if you're not like the biggest outdoors fan, there are other things you can do to boost attentional capacity that have been pretty well studied. So I'd say, like, my advisor always says the nature literature is like 20 years behind the exercise literature. So the benefits, the neurological benefits of exercise are really widely studied and are very, very robust. We're just kind of starting to apply those methods to looking at nature and natural environments. But if nature's not your thing, don't worry. There's other ways you can kind of boost attention and reduce stress. So, exercise, meditation being some of the other things that you can do. Yeah. Anything else? Thank you. Hope to see you in class.